Hello, I'm Professor Barbara Sahakian from the University of Cambridge. In my talk, I will argue that there is nothing more important than good brain health, and that mental health and well-being is the biggest challenge for the 21st century. What can we do about this challenge? Well, through innovation and technology, including games, we can promote better brain health and well-being for all members of society. To find out how we can do this, watch my talk, Games for the Brain.
So welcome to the 6th of the 2016 Darwin College Lectures on the theme of games. So far in this series, we've been to the Olympics, visited Iraq and Afghanistan, and linked the 3 W's, Westminster, Wormwood Scrubs, and Wittgenstein. Tonight, we turn to science. Know thyself, the Delphic maxim. So as Alexander Pope pointed out, we're good at measuring Earth, weighing air, and stating the tides. But do the glories, jests, and riddles of the world know themselves? The brain is a chaos of thought and passion, all confused, still by himself abused or disabused, created half to rise and half to fall. That's Pope's view. To still that chaos and help us know ourselves, as we search for good brain health and well-being, our speaker tonight is Professor Barbara Sahakian, from the Department of Psychiatry and the MRC Wellcome Trust Behavioural and Clinical Neuroscience Institute right here in Cambridge. So Barbara is a distinguished clinical neurophysiologist, well known for her research on psychopharmacology and the early detection of Alzheimer's, and co-author of a book, Bad Moves, How Decision-Making Goes Wrong and the Ethics of Smart Drugs. She's past president of the British Association of Psychopharmacology, and as you can see from here, president of the International Neuroethics Society. So please welcome Barbara Sahakian to speak on Games for the Brain.
Thank you. Well, I'm really delighted to be invited to give a Darwin lecture, and it's a particular pleasure because, as you can see, I did my PhD at Darwin College. So I'd like to ask the audience, how many of you go jogging, exercise, go for walks, or keep tabs on the number of steps you do each day? Please raise your hand if you engage in any of this activity. Well, look at this. This is very good. This is excellent. Quite a few of you do, and that's a very good thing. Exercise is good for your physical health, your mood, and your cognition. But while it's obvious that many of us in society are concerned with our physical health and monitoring it with wearable tech and other devices, we are much less concerned about our cognition and our mental well-being. In this talk, I will argue that there is nothing more important than good brain health, and that mental health and well-being is the biggest challenge of the 21st century. For example, do you know that 1 in 4 of us will have a mental health disorder at some point in our lives? So that's a lot of people. I will also suggest that while we're using technological advances such as Fitbits and other wearable tech to promote good physical health, we are not using technological innovation to promote good brain health and to prevent, detect, and treat mental health disorders. Therefore, I will focus on the importance of using technological innovation, including games, to promote better cognition and motivation in people in the early stages of Alzheimer's disease, and also those with schizophrenia, as well as healthy people. And since I can see a number of young scientists in the audience, I hope that you will consider joining us in working towards improving brain health and well-being for all members of the society through the use of technology. So did you know that mental ill health is the single largest cause of disability in the UK? It's bigger than cancer and bigger than cardiovascular disease. Now, I work on dementia, schizophrenia, and depression, and you can see the annual costs of these. But the actual financial cost is nothing compared to the cost to well-being, both to the patients and also to the families. So it's a very, very important topic, and as I said, it is the big challenge of this century. Now, dementia, as you know, will affect older people, but schizophrenia affects young adults, and it can be lifelong. Likewise, depression can be recurring throughout life. So it's very important, as I'll be arguing, that we detect these disorders early and treat them early and effectively so people can have a very good life course. And I'd also like to encourage some of the young scientists in the audience to think about government policy. I've worked on all these policy pieces that you can see up here, and this is really, I'm involved in the neuroscience and mental health policy. And through policy, we've been able to shift to focusing on early detection and early effective treatment. And perhaps in the future, we'll actually be able to address prevention. And the reason I got involved in this was that so much of the time throughout my life as a clinical psychologist, I'd be treating patients. And for instance, when I was at the Institute of Psychiatry, working in this section of old age psychiatry, I'd be seeing an elderly person with depression. And in those days, we didn't have the electronic case notes, we had paper case notes. And so I'd order the case notes up so I could look at the case and study it before I saw the patient. And somebody would come up with a big trolley, and first they'd plunk one stack of case notes on my desk, and then they'd plunk another stack of case notes on my desk. And that poor person had essentially gone through life with recurring bouts of depression, which is chronic and relapsing. And you can imagine the impact on your well-being if this is what's happened to you. So the idea is that if we can detect mental health disorders early and treat them early and effectively, people will have a good outcome and a good sense of well-being. And you probably don't realize, but for obsessive compulsive disorder, the average time till diagnosis, the average time till it's noticed and diagnosed is 11 years. So this is very different. You can see that there's no parity with physical health because physical health problems are usually detected so much faster. Well, I, of course, work on cognition. And one important thing that we've now realized is that the psychiatric disorders are disorders of cognition. They're all about the way that you think, and they're all about problems of cognition which impact on your functionality and your ability to work and hold down a place at university. So many neuropsychiatric disorders are actually of neurodevelopmental origin with an onset or prodromal stage in childhood or adolescence. And indeed, mental disorders disproportionately affect the young, with 75% of illnesses having an onset before the age of 24 years. Well, what are these cognitive manifestations that people might have who have disorders of cognition due to psychiatric disorders? They're what we call attentional biases, problems of learning, memory impairments, dysfunctional reward systems, and importantly, lack of top-down cognitive control by our prefrontal cortex. And it's perhaps not surprising that we have this kind of lack of top-down cognitive control by prefrontal cortex, because we now know that our brains are still in development up until late adolescence, early young adulthood, and in fact up until 24 to 25 years of age. And so it's perhaps not surprising that certain environmental influences, such as stresses or substance abuse, can have a bigger impact on the brain during this time when the brain is in development. Well, I had the privilege of working on the UK government foresight project on mental capital and well-being. And the government wanted us to work on this project for two important reasons in particular. And one was they were concerned that with the aging population in the UK, and age being the big risk factor for Alzheimer's disease, that there would be many people developing Alzheimer's disease. So they wanted to know, how could we keep our brains functioning better for longer throughout the whole life course? The other problem that they wanted us to address was a financial one for businesses, and that was days lost at work due to depression. And what they found was that they had problems of what's called absenteeism, where people got depressed and they didn't come to work, and that was expensive for businesses. And also presenteeism, when people came back from work, sometimes they weren't as productive as they should be, weren't functioning as well. And they wanted us to figure out how we could help people have good mental well-being throughout their whole life course. And in working on this project, we took which was rather unusual at that time, a life course approach to the project, looking at what happens in early development, as I showed you with the brain development, but also what happens in later life as well. And we identified these promoter factors for good brain health, and those are the circles here pointing up in blue, and there's such thing as a good education, good social support systems. And we also identified things that detracted from good brain health and mental capital, such things as stress and substance abuse. And part of the project also was to find biomarkers. And we wanted to find these biomarkers so we could prevent, hopefully, eventually, but also at least detect early and effectively treat these mental health disorders. And biomarkers can include cognitive measures, which of course is my area, neuroimaging, which I also work on, and then genetics and blood-based measures as well. Now I'll just show you part of what the problem is all about. This is what you have to have in order to get a diagnosis of Alzheimer's disease. So obviously, Alzheimer's disease is a dementia and your cognition becomes impaired. But you don't have to just have the memory impairment, which is what is the early sign that you pick up when you're detecting it early. You have to have a problem in at least another area of cognition, such as language or motor sequencing or naming. Furthermore, this decline has to be from a previous higher level of functioning. And importantly, it has to be sufficiently severe that it actually causes an impairment in your occupational or social functioning. So you can see what the problem is. By the time you're detected, you already have problems at work and problems at home in your family life. And this just isn't good enough. We need to be detecting people earlier so we can prevent this sort of decline. And as I'll be arguing, while brain scanning and other techniques may assist in diagnosis and monitoring change, they must be combined with cognitive measures which indicate decline. And I'll be showing you the ones that we developed. So fortunately, we know a lot about the neuropathological basis of the cognitive problems in Alzheimer's disease. And we know, for instance, that destruction of the basal forebrain leads to loss of acetylcholine throughout the brain, a chemical called acetylcholine. And actually, this is the mechanism by which the current treatments that we have, the cholinesterase inhibitors, work. They boost acetylcholine in the brain. And I had the opportunity some years ago when these were being identified and developed to do the proof of concept studies for these drugs. So at that time, in the UK, we didn't really have memory clinics. We set up one of the first memory clinics for early detection of Alzheimer's disease because we knew if we were going to treat with a drug that the brain had to be intact. We had to have the neurocircuitry. The drug had to work through good circuitry in the brain. So we wanted to detect people early, and we also thought that we could prevent them having decline, or at least slow down the decline with these drugs, which were symptomatic treatments. So we didn't expect them to halt the underlying disease process, but we did think that they would treat the cognitive symptoms of the disorder. Well, the studies that I did with Raymond Levy and Sarah Eager were published in The Lancet some years ago now, because as you know, we have nice approved drugs like Aricept and Epizil for the treatment of Alzheimer's disease, and these are the cholinesterase inhibitors. But what we found in these studies was that these drugs, the cholinesterase inhibitors, were very good at treating the attentional and concentration problems of Alzheimer's disease, but not so good on the memory problems. We also know that very early on in Alzheimer's disease, we get cell loss in the hippocampal formation. And that is what causes the problem in what we call episodic memory. Now, episodic memory is very important because it's a type of memory that we use all the time, every day. So, for example, trying to find your car in a multi-story car park, trying to remember where you parked it, that's episodic memory. Trying to remember where you left your keys in the house because you're trying to go out, that's episodic memory. So we know that this cell loss occurs very early in the course of the disease, and we know it's responsible for episodic memory. And that's important for the test I'll be showing you later on for early detection of Alzheimer's disease. And then a bit later on, we get cell loss in the temporal neocortex, and that's responsible for the deficits or problems in semantic memory. And semantic memory is knowledge for facts, so it's knowing that David Cameron is our prime minister, that type of fact. Well, we're very lucky at the moment because several companies, including Lilly, Johnson & Johnson, Pfizer, are all working on drug treatments for Alzheimer's disease. And Lilly and J&J are actually trying to develop neuroprotective drugs. So these won't be just like the symptomatic treatments like Aricept and donepezil, which treat the sort of attention concentration symptoms of Alzheimer's disease, but these will actually halt the underlying disease process. So we'd be delighted when they come along. But you can understand that it's even more important that we're able to detect early, because we want to put these drugs into people while they're still enjoying their life, they have a good quality of life, they're still working, and they're still engaging in their family activities. There are also some drugs that are coming along which will address some of the symptomatic treatments as well, and we really do need a good drug to treat the episodic memory problems that is seen in Alzheimer's disease. So this just shows you that sadly there is a decline in cognition with normal aging. And we are functioning at our best in our 20s. But you can see here that we have the symptomatic treatments, these Aricept and Epizil that I mentioned, the cholinesterase inhibitors that NICE approves, that can be put in here. And they will help for a very long time. As I'll be showing, they keep us from going into institutionalized care longer. But here is where we want to put in these neuroprotective agents, just as we're separating from this line of normal cognitive decline. And up here is what we call mild cognitive impairment, the early or prodromal stages of Alzheimer's disease. And as I mentioned, it is important to treat with the current treatments that we have because first of all, it keeps people out of institutionalized care. They can stay in their own homes for longer, which is what people want to do. And also, it saves the government lots of money. So it's very important. So to treat is a good thing. And the Prime Minister pointed out in his speech in 2012 that today only around 40% of people with dementia are actually diagnosed or know that they have it. And he stated that we can help people live independently for longer, even put the brakes on their decline. So it's very important to have this early detection and treatment. Well, I'm now going to talk about the Cantab tests, and those are the tests that I co-developed with Trevor Robbins here in Cambridge. And we wanted to use this innovative touchscreen technology to ensure that we could detect early and put the tests that we were using onto this kind of iPad mobile type of technology. And that's been done more recently by the company Cambridge Cognition. But these tests use touchscreen technology very early, before you found them on your phones and before you could use them in other places. So we were one of the earliest groups to adopt touchscreen technology. And the computerized tests that we have called Cantab are now used in over 500 universities in over 50 countries. So it's very, very exciting that they've been well used. And in fact, they've been, through the university, technology transferred to Cambridge Cognition, and Cambridge Cognition has been commented on for their work in developing new tests for Alzheimer's disease by the Prime Minister in his G8 speech in 2013. So there's been very good development of these tests. And what I would say to you young people is that, young scientists, is when we have a good idea, try to get out there with it, because you want to make sure that it has impact on society. The point of science is to improve society, to provide benefits for it. And so you have to be able to get your new discoveries and inventions out there so that they can be used. So as I mentioned, episodic memory is all about, trying to remember the locations of objects in space. Where did I park my car? Where did I leave my keys? It's that type of memory we use all the time. And it involves the hippocampus in the neural network when we utilize our episodic memory. So I'll show you how our test works. It's a very, very simple test for early detection. So you can actually test yourselves and see if you're all okay out there. So what happens, and this is one of the more difficult stages, you have 6 boxes coming on the screen, and I say to you, okay, there's 6 boxes on the screen. There's going to be a different object in each of the 6 boxes. I want you to remember which object is in which box. So you have to remember which object is in which box. So remember where that is. Remember where that is. And that one. And that one. And that one. And that one. And then this one comes up in the middle. Does anybody know where it was? Yeah, so it was in the upper left-hand box there. So that's how that works. Very simple, but it's a very good way. It's a very good, essentially, it tests the hippocampal formation function. And of course, we've had to do studies over a whole number of years to validate the test clinically. So we've been able to show that it's very sensitive to mild cases of Alzheimer's disease. We've been able to show that it's sensitive to the change from what we call mild cognitive impairment, the very early stages, to Alzheimer's disease. And we've been able to give it to people who are in the healthy elderly population, and then detect who in that population has actually got the early stages of Alzheimer's disease on follow-up 5 years later. So we've done all these tests, and as I said, not only, I should point out that not only is episodic memory related to the functional outcome in Alzheimer's disease, but it's also related to functional outcome in schizophrenia. And I'll be talking about schizophrenia a bit later. So what has moved on is that transferring it to Cambridge Cognition has made a big advantage, because they've been able to put it on a mobile platform. And so now it can be used in GP surgeries, and it's used in over 260 GP practices in the UK. So the GP can assess whether somebody who's elderly has a memory problem. They actually have a tool to do that. And the GP doesn't have to give the test themselves. They can have a receptionist or a nurse give the test. It's very simple. It only takes about 10 minutes. And what is useful for the GP is it gives a readout of a green light, which suggests there's no concerns about this person. They're performing just the way they should for their age, or that they need to be monitored. There's not something that doesn't look quite right, or that they need to go for further investigation. So it makes it very easy for them. And the nice thing is that with this technology, the data comes back in the cloud. So you can aggregate anonymous data around the country, and you can see where it's being used, and you can track for the purposes of planning health services who is actually having this type of memory problem and who is fine. So it's a very simple way to get data back. Well, we're using it also, this test, in a study with the lead is Simon Lovestone, who's based in Oxford now. And this is called deep infrequent phenotyping in Alzheimer's disease. And what we're doing within this study is we're looking at these cognitive biomarkers, but we're also looking at other biomarkers, for instance, positron emission tomography, PET scanning, and also neuroimaging of other sorts. So functional neuroimaging and MRI. We also are taking CSF and blood biomarkers. And we hope that we will be able to understand what's going to help us detect very early on, because we're now beginning to realize that some of the changes in the brain are actually occurring as young as 40 years of age or maybe even earlier. So we want to make sure that we detect people before the damage is done. And when we have these neuroprotective drugs, not only do we have a population where we can offer these drugs to see if they're effective, but we can also, when the drug is finally approved by the FDA and the EMA, we know who to give them to right away so that they can halt the underlying disease process, and that will be of great benefit. Well, this slide is really to show you two things. One is that when we put somebody in the scanner, we ask them to do this task, the episodic memory task in the scanner, you could see that it activates the hippocampus. What it also shows you is the difference between healthy control subjects and patients with mild cognitive impairment. Now, I showed you the task at the level of 6 items in a box, but there's also an easier level of 4 items in a box, in the 6 boxes, and there's a harder level where 2 more boxes come on the screen, and there's actually 8 boxes, and they're each filled with something. And what this shows you is that the healthy controls don't really have to activate very much until it gets to something in each of the 6 boxes, like the level that I showed you. And then they stay up activating for the 8 boxes, and of course their performance is very good. But what you can see with the mild cognitive impairment patients, or the ones in the early stages of Alzheimer's disease, is that they have to maximally activate at the level of 4, and then slowly they have problems with the task and the activation comes down. Now, we could use this if we had a drug which we thought was going to improve episodic memory. We could give it to people, put them in the scanner, and we would hope that these MCI patients, that their performance would look more like this. So this is a model system where we could very quickly see whether a drug is going to improve episodic memory and restore that functioning that we want to see. Well, now we get on to games. And I want to talk about our approach to games because it's been a very neurobiological approach to improving episodic memory. And basically what we've done is we know that cognitive training actually works in psychology. It's a well-used technique or method in neuropsychology that you actually give people tests that have to do with improving their memory, and you try to work on their memory function by, essentially training them and testing them. Now, the problem with that is, it's a very good method, it works very well, but it's not very interesting. It's a chore for most people. Sometimes there'll be a lot of dropout because people don't want to continue doing it. And also it requires staff. And if it requires a psychologist to deliver this, it could be quite expensive. And obviously it can't be offered to lots of people because there'll be a waiting list for people to be able to do this. So what we wanted to do was to make cognitive training much more fun by gamification. And we wanted to do this by developing, we had the background, the experimental evidence about the neurocircuitry that underlines episodic memory, so we could do this in a very strategic way. And developing our first game took about 9 months. And we were very lucky because I put out an advert for a games developer, and we got this wonderful person called Tom Piercy, who's sitting in the front row here. And he decided to give up all the money and glory from making games that were often used in a betting context to come in and work and do some good for society. So that was great. He took a big pay cut for that, of course, but anyway, I hope he enjoys his work much more now. So in my lab, we have a lot of different people. We have a professional games developer, we have neuroscientists, we have psychologists, and importantly, we also interacted with the people who were going to use the game. Because how do you know that they're going to understand what they're doing, or that it's even fun or interesting to do, if you don't actually ask them, if you don't let them use it and they give you feedback? So we spent about 9 months developing this based on the evidence that I'd already showed you and that I already have as to what needed to be stimulated to get that episodic neural network working in the brain. And then we made sure that it was fun, and that was really Tom's job. So he did a lot of work with titration so that when the game gets too difficult for somebody, it comes back down again. But then it's also challenging. If you're doing very well, it moves up. So that was one way to get it very engaging and motivating. I showed him, what I wanted the episodic memory game to look like, but then he decided what the theme was going to be. And he picked a wizard's theme because for these people with schizophrenia, but we picked a different kind of theme for the people with mild cognitive impairment, because the people with schizophrenia were about 20 to 30 years of age, so we thought we wanted a wizard theme for them, and everybody knew about Harry Potter and so forth. But with the older people, we thought, well, there are quite a few older people who like to sit around, watch some game shows on TV, but let's make them do the game shows. So we took a game show theme for them. So we had this, made sure that they were motivating and everything else and easy to understand, and this took about 9 months. What we found with the people with mild cognitive impairment, when we actually had them play these games for 8 hours, that they actually showed this improvement on the episodic memory test that I showed you. So you get this nice improvement here with the cognitive training. And also, when we took measures of global cognitive functioning, we saw that improve too after playing the game. And then we found out that in these people with mild cognitive impairment, they felt motivated and enjoyed it. And actually, also, it improved their confidence over time with playing. So we were very pleased with those results. And George Savaluch in the laboratory was one of the drivers for doing these studies. So he's unfortunately not here today, but he did an excellent job with running these studies. So I'll now move on to people with schizophrenia. Well, people with schizophrenia have several problems, 3 problems that are very clear. One are the psychotic symptoms, and most of you will be aware of those because they're what we call florid. They're the delusions, the hallucinations. So you might be hearing voices, or have unusual thoughts. And those are pretty well known by people. But we do have these drugs, which are antipsychotic medications, which reasonably well treat the delusions and hallucinations. So there is a treatment for those, which works, quite well. But the real problem with people with schizophrenia, and many of you might know somebody or have a family member with schizophrenia, is that when they're diagnosed, if they're in, say, university, they may drop out of university and never go back, or they may drop out of work, if they're at work, and not go back. And the reason for that is the cognitive disability that they have, the cognitive problems. And we now know that it's actually not the psychotic symptoms, but the cognitive problems, which are the biggest barrier to them rehabilitating and having a good quality of life, going back to work, going back to university. So because of that, the Food and Drug Administration, the FDA, has made the cognitive problems in schizophrenia a target for treatment. But unfortunately, we don't have any medications that will treat those. So the other problem is the motivational deficits that they have. So they have really significant motivational deficits, and this is also a barrier to rehabilitation. So they also need to be treated effectively. And what we showed some years ago was, again, that these problems in episodic memory that people have, some of them, of these people with schizophrenia, the problems in episodic memory can be as bad as what you would see in Alzheimer's disease. And what we showed was that these are also related to functional outcome, as I said earlier. So the episodic memory problems are very closely linked, both in Alzheimer's disease and schizophrenia, to how you do in your daily life. So if we could treat that, we might very well improve the functional outcome of people, how they do in their daily lives, how they do at work. So again, we know that cognitive training actually works. It's a well-used technique by neuropsychologists and psychologists. And there's been a meta-analysis which shows that if you cognitively train, especially if you add in another form of rehabilitation, you get good effect sizes, good improvements. So if you cognitively train, you get an effect on cognition, but importantly, you also get an effect on psychosocial functioning. So it does improve your ability to function in daily life. However, the dropout from some of these studies can be extremely large, probably due to lack of motivation. And then again, the cost of the financial delivery can be high. So, as I mentioned, we developed this wizard memory game, as you can see here. And what we found was that playing this game over 8 hours, they showed enjoyment, so they were well motivated, and they wanted to continue. They rated that they wanted to continue playing the game. And you can see here that their episodic memory improved, and they had better functioning. When we asked them, what did you think of it, they made comments like they liked the fact that the difficulty increased just slowly, and they liked it, that it was challenging, and they felt that they had achieved something from the progress in the game, and they basically found that it was fun and colorful. And just recently, we've actually tech transferred this again through the University Cambridge enterprise to a fantastic games company called Peak. And they've adapted the Wizard Memory game for phones, so that many people don't have iPads, but everybody basically has a mobile phone. So now it can be accessible to anybody via Peak on your mobile phone. So we're really pleased about that, because many people have asked to use it, and this is a way of getting it out there. So I'm going to talk about another kind of cognitive function now. Now, I was talking about episodic memory, which is, as you saw, was related to hippocampal formation, sort of behind the ear type area. But in the front of our brains, we have these executive functions. And one of the key functions is strategic working memory. And the importance of working memory is it is a really core component of most higher level or executive function tasks. So whenever you're planning or problem solving, there will be a component of that which is working memory. So for example, if I'm putting together this talk for tonight, I might think, okay, well, what do I need to explain this talk? Okay, well, some people might not know what episodic memory is, so let me get a slide and put that together of episodic memory. And I'll be pulling things together while I'm working on them. And then maybe I'll pull in something else and say, perhaps I'll talk about ADHD, and then I'll think, no, that's too many disorders to talk about. I'll just not speak about that one. So I'll chuck that out. I'll decide not to do that. And that's our working memory. So we keep things in that memory for as long as we need them, and then we throw them out. A very, very simple form is when in the old days, when you used to look up numbers in a phone book, you might open the phone book and go 01223 331209, 01223 331209, and then you dial it and close the book. And if you got through on that phone call, it was fine. But if you got a busy tone, you suddenly think, what was that number? What was it? I just had it in my... But the point was that you threw it out because you thought you used it and you didn't need it anymore. Can you imagine if we tried to remember every single number there is? I mean, most of us have trouble with a few, passcodes to get onto the computer or something else. So we don't want all these other numbers as well. So it's that kind of thing. Now, the other importance about working memory is it's been shown to be related to what we call fluid intelligence, which is creative intelligence, and also crystallized intelligence. And crystallized intelligence is what I might measure when I'm testing somebody with the Wechsler Adult Intelligence Scale, or your IQ. So if you're measuring IQ, that's crystallized intelligence. So it might be that if you can improve working memory, you have a leverage to affect creative intelligence and crystallized intelligence. So it's important for those reasons as well. And then it is also, working memory is affected in many of the neuropsychiatric disorders, including ADHD and schizophrenia. So I'll show you our Cantab test of spatial working memory, and this is how it works. Again, a very simple test. It's on an iPad with a touch-sensitive screen like the other test was. And what I'm going to do is say to you, I'd like you to search through these red boxes to find a blue square. And when you find a blue square, put it over here. Now, the important thing to remember is once the computer has hidden a blue square inside a red box, it will never hide it in that same box again. So never go back to a red square where you found a blue box. So then I say, okay, well, touch a box and open it up and see if there's a square. Nothing in there. So you touch the next one, nothing there, nothing there. Found a blue square, so then we move it over to that column. And then the important thing is not to touch that box again, and if you do, that's an error. So you start your search again, there, and now we know to jump over this next one. Don't touch this next box. We go there, we found a blue square, and we move it over. Very simple, that's working memory. But as you can see here, working memory is very much impaired in first episode psychosis and also patients with schizophrenia compared to healthy controls. And that's work by Chris Pantelis's group in Australia. So I'm just going to talk about another way that we work in my laboratory, which is a psychopharmacology laboratory, to boost cognition. And we use drugs as tools to boost cognition. And most of you will be very familiar with methylphenidate or Ritalin because it is NICE approved for the treatment of attention deficit hyperactivity disorder. And another drug which is also used for treatment of ADHD is atomoxetine. I won't be talking about them today, but I will be talking about modafinil. Now, modafinil is a very interesting drug, and as some of you probably realize, I work on what's called smart drugs or cognitive enhancing drugs. And I use them in the context mainly of neuropsychiatric disorders or to probe the brain, because in a psychopharmacology laboratory, you can use drugs as tools to understand how chemicals in the brain modulate our cognitive function. So if I want to know in a healthy brain how I can, does dopamine, does noradrenaline affect cognitive function in terms of, say, working memory or episodic memory, I can use these drugs in a healthy person to see what happens and to see whether it's improved. And in the course of that, of course, some of what I've discovered is that healthy people are using these drugs, these smart drugs, and trying to boost their cognition. But I'm now talking in the context of disorder. So modafinil is an interesting drug, and of course it's approved in the UK for narcolepsy, which is excessive daytime sleepiness. Now, I always explain to my audience that if you fall asleep while I'm lecturing, well, it's that time of day, and you're probably a bit tired, you've been at work or been out all day, and, the lights come down and you fall asleep. But if I fall asleep while I'm talking, that's narcolepsy. So we don't quite know how modafinil exerts its cognitive enhancing effects, but we do know that it acts on the transmitters, the chemicals in the brain, noradrenaline and dopamine, and we know that these are important for other actions of cognitive enhancing drugs. So we know for sure that these are involved. It also affects glutamate, which is very important, so that's how we think that these drugs are acting. Well, what we've done in one of our studies is to add modafinil on to antipsychotic medication in patients with psychosis, as you can see here, and it improves their cognition in terms of the spatial working memory task. So that gives them benefit. So that may be a very useful way to improve cognition in this group. Interestingly, of course, you can see here when we give it to healthy people, we also get a nice improvement. So it improves both groups. In this very recent work, which is a part of a PhD of Mustafa Kazir. Where are you, Mustafa? You must be here somewhere. Oh, yes, there, he's over there. So he's done this excellent piece of work where we were trying to help people get back to work and give them the ability to actually do their work performance better by adding on modafinil to, some of them are still on antidepressants, but some of them have come off the antidepressants, they're recovered from the depression. And in this study, which has only just been completed, we found that spatial working memory is improved by modafinil. So this is very encouraging because this may be a big help to improving people's ability so that presenteeism will go down. They'll be much better at their work performance. And also we have found in our other studies that modafinil improves task-related motivations, so it can also help in performance of a task. Likewise, we found that in our meta-analysis that we did, that modafinil added on to antidepressants when you are depressed actually improves your outcome. So it does seem that it might be a very helpful drug for treating both the cognitive and some of the mood symptoms of depression. And importantly, you can see that we found that spatial working memory was shown to have a relationship with work performance. So it should be very strongly related to their performance when they get back to their jobs. So I'm going to finish off this talk with talking about some of the possible methods that healthy people can actually boost their cognitive function. So one of my favorite ones is education because, being an academic, I am very keen on education, and it has been shown to be a fantastic way to boost your brain power. Lifelong learning is very good for you. And we also know that exercise, physical exercise, can be very good for you. And that's another way that we can boost our cognition. And what you can see here is that physical exercise actually increases neurogenesis in the brain, so you get new brain cells. And then also, we can activate our neural network through cognitive training through these games, and hopefully boost our cognition through that method as well. So thinking about exercise, there's some fantastic work, quite a lot of work now, showing that exercise improves cognition. And this, again, can have important implications for functional outcome. So looking at this graph up here, you can see that mathematical achievement is improved through exercise. And likewise, reading achievement is improved through exercise in these children, aged 9 to 10 years. So that's very important, and I don't think we ensure that our children get enough exercise most of the time. It's important that they get out there and exercise. It's important for all of us, actually. Because if you look here, at the other end of the spectrum, if we look at healthy older adults, you do better with high exercise. You can see there's an improvement in cognition, and you actually live longer. So that's another good reason for exercising. So across the whole spectrum, a whole lifespan, exercise is good for you. Well, I was interested in, cognitive training, cognitive activation, driving the neurocircuitry in the brain many years ago. And I did published an article in the British Medical Journal, the BMJ, with Martin Orell in 1995, which was about use it or lose it. And it was really about trying to identify the underlying neurobiology of how working and using your brain made you function better cognitively. But there's been some more recent studies that are very exciting, and these have been mainly carried out in the Torkel Klingberg lab with healthy people, where what he's done is, you saw my working memory test. He's using a working memory test, a different one. And what he's done was he's trained healthy people for 14 hours over 5 weeks. And he actually has measured the brain changes that you see in these healthy people. So he got increased activation in the working memory neural network. And he also got changes in dopamine receptor D1 binding potential in the same areas. And we're very, as you heard, some of the cognitive enhancing drugs that we know about work through dopamine and noradrenaline. So it's very interesting that through this means we can actually change the chemicals in the brain. Some of you will also be familiar with, because it's quite famous now, the very elegant studies done by Eleanor Maguire at University College London. And there she studied taxi drivers. And as you'll know, the London taxi drivers are quite amazing because they have to know the knowledge. They have to get the knowledge. And the knowledge is, how do you get to everywhere in London? And how do you find shortcut routes when one route is blocked? So they have to know all this knowledge which they're tested on. And what she was able to show by placing these taxi drivers and neuroimaging their brains was that the size of the hippocampus was related to the time they spent as a taxi driver. So they actually had larger hippocampuses the longer they'd been taxi drivers. So it's really amazing, but I think it's very strongly a use it or lose it idea. Well, again, I've been very lucky to work with Peak, and we've, for healthy people, they've been able to develop this game, which again runs on a phone. And I think Erman's here. Erman? Oh, there he is, over in the corner. And he's kindly brought with him 100 cards to make the Peak game available for the first time. Have you actually got the cards on you, Erman? Oh, good. Well, save a few for me, won't you? But otherwise, I'd suggest that you all attack him at the end of the talk and grab a card off of him. But it's great because, you know, we've been able to make this available for people to, you know, work to improve their memory function. And it's a very exciting game, as you'll see. At least 100 of you will. So I just want to show you some of the new developments coming out of the laboratory. And we've been working, because I also work on attention deficit hyperactivity disorder, and I work both with children and adults, and I've worked a long time with Dr. Ulrich Muller, who works on adult ADHD and has a clinic for that. Because you may not realize it, but about 50% of children with ADHD still have it as an adult. And if they're not treated effectively with the medications that we have, drugs such as methylphenidate, Ritalin, they won't be able to hold down a job because they won't plan well, they won't get to work on time and that type of thing. So it's very important. So we've been very interested because one thing we've thought about is combinations of things that we might be able to use. So for instance, in schizophrenia, mightn't we be able to you know, change the dose of a drug if perhaps if we increase the motivation through use of a game and we help people with their cognition, perhaps they will find other means of controlling the hallucinations and delusions. Now, I wouldn't say that they need to, you know, come off their medication, but what I would say is that we might be able to lower doses of drugs. And it may be more true in such areas such as attention deficit hyperactivity disorder. Perhaps if you're able to develop your own ability to sustain attention, you might not need as much Ritalin or methylphenidate. So there may be that through using these techniques, we can actually also reduce medication for people, because some people don't want to take the medication and some people don't like the side effects of the medication, or the side effects they find problematic for them. So the reason I've stopped it here is because this goes very quickly. So there'll be a lot of numbers coming at you, and you have to detect the sequence that you'll see on the side of this. So I'll start it going, and you'll see that you have to detect when 5, 8, and 3 come up in a row. Okay, so you saw that at the end. So we've been very lucky. I was contacted by the Science Museum in London, and they wanted to have a festival of human enhancement, and they wanted to think about smart drugs and cognitive enhancement in terms of pharmacological cognitive enhancement, but also other ways to boost your cognition. And I believe Peak was also involved in this, and we brought our attention and concentration game down there, and lots of people enjoyed it. And in this picture here, you can see George Savaluch and Tom Piercy, who were helping with this, and other members from our laboratory, students who came over from the Netherlands who were in there for a short period of time. And people really enjoyed it, and they also found out a lot about, you know, enhancing your brain and about good brain health. So that was a very nice event to be involved in. So I've been focusing mainly on what's called cold cognition. So in healthy people, we normally have a good balance between our cold and our hot cognition. Cold cognition is a type of cognition that I've been showing you the tests of, the sort of spatial working memory test, the Cantab PAL test, episodic memory test. These are all forms of cold cognition. They're non-emotional. And I often describe the two, and it makes it easier when I talk about what might happen in, for instance, when you're involved with entrepreneurs or something like that. So suppose you're doing a business plan and you have to say, okay, I'm going to make something, a widget, and now I need to identify my market, who am I going to sell this to, and then how much is it going to cost for me to make this thing, and how much of a margin profit should I try to get for selling it? So you've got your plan, and you work out that, and that's cold cognition. Or even for most of us, what are we going to do today? Let's organize our schedules so we can get the most out of the day, be as productive as possible, make sure we're at the right place at the right time. That's cold cognition. Hot cognition is, I don't know how many of you have seen Dragon's Den, but that's kind of hot cognition. People come in and they pitch to you, and immediately you get this feeling that somebody's got a good idea, they know what they're doing, but somebody else doesn't seem to know. And that's a kind of almost a gut sensation. Another kind of hot cognition is the type of thing I often explain when I'm talking to my students, that it's the type of thing where you have to make a decision. All your mates are going out drinking because they finished their exams, and you haven't finished your exam. You've still got one left. And they all say, oh, come out with us. Come have a drink with us. And by the way, that man you're interested is coming with us too. So, why don't you get a chance to meet him if you come with us. And then you have to make this decision. Do I just throw caution to the wind and go rushing out drinking with my friends and have a great time, and then maybe when I do my exam tomorrow, I've forgotten all the material and I wake up with a hangover. Do I even get to my exam on time? So it's that kind of decision. So you have a lot to gain because you want to meet this person and you want to have fun with your friends. There's a lot of reward involved in doing all that, but a lot to lose, because if you mess up your exams, then that's not very good at all. And of course, I know that Cambridge students always make the right decisions. So that's a very good thing. But it's that type of decision where risk is pitted against maybe, you have to make a risky decision, and reward is pitted against punishment, essentially, that type of thing. And interestingly, in the brain, you can see there are different, these are the 5 parallel and partially segregated loops that were just described by Alexander DeLong and Strict. These are 4 of the 5 loops. And this is the cold loop. But the hot loop involves, and this cold loop involves dorsolateral prefrontal cortex, very important area for the working memory task I showed you. And this is the hot loop, the affective loop, the emotional loop. And this also helps us read people, which is so important to know when your social cognition, is somebody getting bored, or this helps you out with that. And it's because this area of the brain, the orbital frontal cortex, is very linked to the emotional brain areas such as the amygdala. And of course, the neurotransmitters I've been talking about, dopamine, noradrenaline, and also serotonin, influence these areas of the brain. So what I wanted to show you is this drug, modafinil, also improves hot cognition. So it can improve emotional processing in first episode psychosis, the early stages of schizophrenia. So what you can see is we show them faces. In this case, you can see it's clearly a happy face, and they have to decide what is the expression, the emotion on the face. And here we can find that modafinil can improve that. Well, this is our most recent invention that we've been working on, and we've been developing tests for what we call hot cognition. And this is essentially a Cantab, but for emotional and social processing. It's got tests of emotional and social processing, also impulsivity and motivation and reward. And this was a collaboration between Cambridge and also Manchester and UCL and King's. And one thing I want to point out here is how nice science is. It's a family. Here's myself, obviously. Here's Trevor Robbins, my long-standing collaborator. But there's also Rebecca Elliott, who's now a professor at Manchester, John Reuser, who's now a professor at UCL, and Mitchell Mehta, who's a reader at King's. All 3 of them were my PhD students here at Cambridge. So it's just wonderful how you can develop a field, have people go off and do things, and then come back together again and do things creative together. And what we realized was, there weren't any good tests that could be run on a computer and be objective of social and emotional cognition. So as we developed Cantab, because I didn't have any good early detection tests for Alzheimer's disease at the time, there were no good ones around, so we had to develop them ourselves. This is what we're doing here. And these have been tech transferred to Cambridge Cognition, so that will make it much easier. And we've done the initial studies where we've tested 200 healthy volunteers to get some normative data on this, and that's just recently come out online. So I hope I've been able to show you how we can use neuroscience, innovation, and technology to improve brain health and well-being, to ensure that there's a flourishing society for all members of our society. And I think, again, it's very important that since we have the aim of science is to have a beneficial impact on society, I do hope that young scientists that are here today in the audience will do this through their future research and policy work. And you heard about my book from the master on bad moves, so that talks about hot and cold cognition and cognitive enhancing drugs, in case you'd like to hear more about that. And also, Emma Ledger did a very nice piece in Your Voice, which is part of the magazine for the charity Rethink Mental Illness. And if you want to hear more about the study on the games for people with schizophrenia, that's covered in there. So I just wanted to thank my collaborators and my students and postdocs who've contributed so much to this work, and in particular Tom Piercy and George Savaluch and Trevor Robbins, because they have been incredibly helpful in terms of the games, and Trevor has been a long-standing collaborator on my cognitive enhancing work. So I'm very grateful to you for your attention, and if you've enjoyed the lecture, I hope you'll come to the Science Festival event that I've organized. Thank you very much.
Barbara, thank you very much indeed. Perhaps if you'll forgive the rather horrendous pun, your advice that everyone likes to play games, so why not play one that is fun and good for your brain, is most definitely a no-brainer. We should all be doing that. And all of you here in your 20s or younger, you can smile. You've heard you're functioning at your best now, and for the rest of us, it's clearly all downhill and gets worse and worse. So we're past it, but clearly we can do something about it. Play games, exercise, keep learning, and here in a university city, that is what many of us are desperately trying to do all the time, so perhaps it's not all such bad news for the rest of us. Next week, our lecturer will be Professor Nick Davies from the Department of Zoology, and he's going to be considering games that animals play. But to end, thank you again, Barbara, for a fascinating lecture, well worth taking not to heart, but definitely to mind. Thank you.